I'm Trevor, and today we're looking at what happened when Google's AI deeply analyzed more than 10,000 documented Bigfoot sightings. The goal was just to find proof, but what Google's AI managed to find suggests that Bigfoot may be far more intelligent and aware of human observation than researchers ever thought possible. There's something important about the data that the AI uses. These sightings weren't pulled from random internet posts or anything like that. A huge portion of them came from long-running databases that have existed for decades, places where hikers, hunters, forestry workers, and even law enforcement in rural counties had logged encounters going back years. Some of the reports were recent, others had been sitting in archives for decades, rarely compared against anything outside their own system. The more reports I looked at, the more I realized they weren't just random stories. Most of them included the same core information: the date, the location, the time of day, weather conditions, a description of what the witness claimed to see, how long the encounter lasted, and how far away it was. Many reports also included distance estimates, giving a rough idea of how close the witness was to whatever they encountered, and some went even further, referencing physical evidence that had been documented at the time. Footprints that were photographed or cast, broken branches found high off the ground, and in some cases, hair samples that had been collected and stored. I assumed anything connected to older sightings would have disappeared years ago, but some of it was still there, preserved alongside the reports. The more I dug into it, the harder it became to dismiss the entire thing as a collection of campfire stories. Whether the sightings were real or not, some of the reports had been documented far more carefully than I expected. Here's the thing that kept nagging at me though. If this database had existed for years, why had nobody done this kind of analysis before? The answer turned out to be pretty simple once I looked into it. 10,000 reports is an enormous amount of information to go through by hand. Even if you had a team of researchers working on it full-time, cross-referencing every entry against every other entry, looking for patterns across decades and across different regions, you're talking about a project that could take years and still miss things a human brain just isn't built to catch. Nobody had the resources to do it properly, so the database just sat there, growing slowly every year, mostly untouched at any real scale. People would pull individual reports for individual cases, sure, but nobody had ever asked the data itself what it might be hiding when you looked at all of it together. That's exactly the kind of problem AI is supposed to be good at solving. So why Google's AI specifically, and not some other tool built for this kind of thing? The answer has to do with how messy this data actually was. We're not talking about a clean spreadsheet of numbers here. This dataset spanned decades, came from different regions with different reporting standards, and a lot of it was free text, actual written descriptions from witnesses, transcribed differently depending on who logged them and when. Some entries were detailed and precise, others were rougher, shorter, missing pieces here and there. A model built only to crunch clean numerical data wouldn't have been able to handle that. What this needed was something capable of reading through unstructured language, pulling out behavioral details buried inside paragraphs, and still connecting all of that back to the structured fields like date and location. Google's AI was specifically suited for that kind of mixed analysis, which is exactly why it ended up being the tool used here. Once I understood that part, I reached out to try and find whoever had actually run this. It took a bit of searching, but I eventually connected with a researcher who had been involved in running the analysis. I'm not going to get into specifics about where they work, but they've spent years studying wildlife behavior patterns and had been brought in specifically because of that background. When I first talked to them, I'll be honest, they were pretty measured about the whole thing, almost cautious. They'd seen plenty of cryptid-related claims fall apart under real scrutiny before, and they made it clear early on that they weren't interested in hype. They wanted to walk me through this the right way, starting from the beginning, showing me exactly what the model had been asked to do and what it actually returned. That tone changed the more we talked. Not dramatically, not all at once. But by the end of our first real conversation about the findings, I could tell something in their certainty had shifted from where it started. I wanted to understand what shifted it, so we kept talking. The first thing the model flagged was something called a clustering anomaly, and at first that sounded almost too technical to mean anything, so I asked the researcher to break it down for me in plain terms. Sightings, when you map them out geographically and across time, should follow something close to a random distribution if what people are encountering is just wildlife behaving the way wildlife normally behaves. Some clustering happens naturally around habitat, sure, but it should still look reasonably scattered when you zoom out far enough. That's not what the model found. When it mapped all 10,000 sightings across decades, the clustering was tighter and more consistent than natural distribution should ever allow. Specific time windows, specific regions, repeating in a pattern that looked far less random than anyone expected going in. The first reaction wasn't alarm, it was confusion, because patterns like that usually mean you're missing something simple. The problem was, they couldn't immediately tell me what that something was. Naturally, the researchers' first instinct was to explain it away. That's just good science, honestly. When you see something that looks too clean, you assume you're dealing with bias in how the data was collected, not some genuine pattern in the world. Their theory was reporting bias. Certain regions just have more hikers, more hunters, more people out in the woods paying attention. Certain seasons bring more foot traffic than others. If you've got more eyes out there during specific windows, you're naturally going to log more sightings during those windows, regardless of whether the actual creature behavior changed at all. It made sense to me when they explained it. Honestly, it made enough sense that I figured this might be where the story ended, a real-sounding anomaly that collapses the second you control for an obvious variable. So that's exactly what we did next. That possibility had already been tested before our conversation even got that far. Population density in each region, estimated foot traffic based on park and trail usage records, seasonal tourism patterns, all of it factored in to see if the clustering was just a mirror of where and when more people happened to be outside. The clustering didn't go away. It barely moved at all. The analysis had already been run twice independently, half expecting an error to show up somewhere in the way the variables had been applied. The result was the same both times. Even after accounting for every reasonable explanation involving human presence, the pattern held. Sightings were still clustering in ways that didn't track with how many people were simply out there to see something. They showed me the second output during our call. I remember just looking at it for a second, numbers that weren't supposed to survive a correction like that. That was the point where I first noticed their certainty slipping. Once the clustering held up, the model moved on to something even stranger, a phenomenon the study described as movement correlation. This one was about connecting sightings that, on paper, had no business being connected at all. Reports separated by hundreds of miles, sometimes by years, that still showed timing and directional relationships, suggesting some kind of link between them. Not identical sightings, nothing that obvious. But when the model analyzed sequences of reports across large geographic spans, it kept finding the same statistical signature appearing again and again in places where pure chance shouldn't have produced it. The obvious explanation was migration. Large animals move. Entire populations relocate over time, but when those correlations were compared against known migration routes and seasonal movements of documented wildlife, the overlap wasn't nearly strong enough to explain what the model was detecting. The timing kept lining up in ways normal migration behavior shouldn't. Put simply, it looked like something appearing in one region and then surfacing somewhere else months or years later, following a recurring pattern that was difficult to dismiss as coincidence. There was a sense of disbelief when this result first emerged because the immediate question was obvious. What kind of animal could cover that sort of distance with that degree of consistency and still avoid being conclusively documented? That was the moment I noticed the shift in how the researcher was talking about this. Before that, every explanation they offered came with confidence. Reporting bias, population density, the usual suspects you reach for first. But after the movement correlation held up, even after multiple attempts to explain it away with migration patterns or known animal ranges, the tone changed. They stopped offering theories as quickly. They started asking more questions out loud, almost talking to themselves as much as to me. I asked them directly if this was something they'd seen before in any other dataset, any other species. Nothing quite like this showed up anywhere else. Animal movement patterns, even unusual ones, tend to follow some kind of ecological logic you can eventually trace back to food sources, breeding cycles, or territory. This didn't fit any of that. For the first time since we'd started talking, I heard real hesitation in their voice. Not fear exactly, but something close to it. The next thing the model surfaced was an emerging trend that came to be known as the avoidance pattern. And out of everything so far, this was the part that unsettled me the most. Up to that point, every anomaly had focused on where sightings appeared and how they seemed to connect. The next result was different. Instead of looking at the sightings themselves, the model started examining what happened when humans actively tried to observe whatever was producing them. The model cross-referenced sighting frequency in specific areas against the installation dates of trail cameras, research equipment, and drone surveys in those same locations. What it found found was that sighting frequency in those areas dropped sharply almost immediately after new equipment went in, not over months, within days, sometimes less. That kind of drop doesn't read like coincidence, and it doesn't read like normal animal caution either. Most wildlife takes time to register new equipment as a threat, or even notice it's there at all. This was instant, consistent, and it showed up across widely separated regions, with unrelated teams deploying entirely different monitoring systems. 3 separate cases were compared side by side. All 3 showed the same thing. At first, the assumption was that the equipment itself might simply be disturbing the area. Cameras, drones, and survey teams all introduce activity that wildlife could react to. But when locations with similar levels of human activity were compared against monitored sites, that same sharp decline never appeared. Whatever the model was picking up seemed tied specifically to observation efforts, rather than people simply being there. I asked the obvious question: what would it actually mean if that drop was real, and not just some fluke in the data? The answer wasn't straightforward. Animals react instinctively to threats all the time. Loud noises, unfamiliar smells, sudden changes to their environment. But responding to observation efforts that quickly, and doing so consistently across regions where the creatures supposedly had no contact with one another, suggested something that looked less like simple instinct and more like awareness. Awareness of what the equipment was actually for, not just that something new had appeared in the environment, but that the new thing was specifically designed to observe. That's a different category of behavior entirely. Instinct explains caution. It doesn't really explain a pattern that specific. Repeated that consistently, everywhere researchers had tried to set up the same kind of technology. It was the first time the conversation stopped feeling like we were debunking something and started feeling like we were circling something real. The next thing the model pulled up was something called the Convergence anomaly, and this one came from a completely different angle than everything before it. Instead of looking at locations or timing, the model focused purely on the physical descriptions inside the reports: height, build, the texture and color of whatever covered the body, details about the face, the way it moved. What it found was that descriptions from witnesses who had absolutely no connection to each other, different decades, different countries, no shared language, no possible way they'd read each other's accounts, were converging on incredibly specific details that statistically shouldn't align that closely. Not just broad strokes either. We're talking specific proportions, specific details about how the joints seem to bend, things that go beyond what you'd expect from cultural folklore just spreading the same general image around. The researchers' first instinct, like always, was to look for an explanation that didn't require anything strange. And for this one, they actually had a decent theory ready to go. Their theory was cultural cross-contamination. Basically, even if witnesses had never read each other's specific reports, the general idea of what Bigfoot is supposed to look like has been circulating in pop culture for decades. Movies, documentaries, old photographs, all of it shaping a shared mental image that witnesses might unconsciously draw from when describing something they only saw briefly and under stress. It's a reasonable theory. Honestly, it's the one I expected to hold. The theory had already been tested. Sightings from before certain pop culture moments had been isolated and compared against reports logged decades later, long after the modern image of Bigfoot had become widespread, long after the cultural image had fully saturated. The convergence held in both groups. Witnesses describing this thing in the 1960s with none of the cultural reference points later witnesses would have had access to were still landing on details that matched what people were describing decades after. That ruled the theory out pretty cleanly. While the convergence data was being rechecked, something surfaced that nobody had originally gone looking for. A secondary pattern hidden inside the convergence itself. It wasn't just that the physical descriptions matched across decades and across regions with no connection. The deeper pass found that the rate at which new details appeared in witness descriptions, the specific things people started noticing that earlier witnesses hadn't mentioned, followed its own timeline. Almost like the descriptions weren't just static and consistent, but were slowly adding information over time in a way that tracked together across completely separate populations of witnesses. That distinction matters. If this were just shared cultural imagery, you'd expect the details to stay roughly the same over time, maybe drift slightly with whatever movie or photo was popular that decade. What this looked like instead was witnesses across different decades in different parts of the world, gradually noticing the same new things, at roughly the same pace, without any shared source feeding them that information. That's not how cultural contamination works. There wasn't a clean way to explain what the data was actually showing. The next anomaly built directly off the avoidance pattern from earlier and became known as the response pattern once its behavior started to emerge. At that point, the avoidance pattern already felt difficult to explain. If the analysis had ended there, it probably would have remained one of the more unusual findings in the entire project. Instead, the next stage of the model's work asked a different question. What happened when that avoidance continued over time? This time, the model tracked what happened to sighting behavior in areas that stayed under active research for extended periods, not just whether sightings dropped after equipment went in, but how the pattern evolved the longer that observation continued. What it found was that the shift was never gradual. In some regions, after enough time under sustained observation, sighting frequency would suddenly spike, almost like something had decided to become more visible rather than less. In other regions, the opposite happened. Sightings didn't taper off slowly, they stopped completely, all at once, like a switch had been flipped. There was no in-between anywhere in the data, no slow decline, no gradual increase. Every region fell cleanly into one of those two outcomes. We spent a while trying to figure out what might be driving that split. Geography was the obvious place to start. Then came population density, differences in local wildlife, even differences in how individual research teams operated. One by one, those explanations fell away. No single variable consistently predicted what would happen once a region came under long-term observation. That's not how real wildlife populations respond to sustained observation. Normal animal behavior under that kind of pressure is messy and inconsistent, full of individual variation between one population and the next. This wasn't messy at all. Taken at face value, that pattern doesn't read like an animal reacting to pressure the way animals normally do. It reads like a decision, like whatever was out there had assessed each situation individually and chosen one of two responses, consistently, every time. Neither of us wanted to commit to that idea yet, not with more of the analysis still left to go through. So we kept circling around it, working through what kind of behavioral framework could even produce a clean binary outcome like that. Nothing in known animal behavior fit. The closest comparison either of us could land on wasn't animal behavior at all. It was something closer to strategy. By this point, there was a real problem. Every theory that should have explained these patterns away had been tested and had failed to hold up. Reporting bias didn't survive correction. Cultural contamination didn't survive the timeline comparison. Normal migratory or territorial behavior didn't explain the movement correlation. And the avoidance pattern kept pointing towards something that looked a lot like awareness rather than instinct. There was one more piece of the original analysis I hadn't been shown yet. It had been mentioned early on, almost in passing, then the conversation kept steering elsewhere every time I brought it back up. A deeper output from the model, the one meant to explain what was actually connecting all of these separate anomalies together. There was real hesitation around getting into it, not because it hadn't been seen already, but because of what it implied once you actually sat with it. I was expecting some hidden variable to finally appear, some environmental factor nobody had considered yet, some statistical quirk that would pull all of this back into familiar territory. Until then, every anomaly still felt like something that might eventually be explained away if you dug deep enough. What came next wasn't that, I asked directly. I needed to understand it, not just hear that it existed. That's when I finally got the full picture. What that deeper output contained didn't seem like much at first. It was a single line buried among pages of analysis. But once I understood what the model was actually saying, it changed the way I looked at everything that came before it. Everything we'd looked at so far treated the 10,000 sightings as separate events spread across decades and regions. Somewhere in that deeper pass, the model stopped looking at them that way. Instead, it started treating all of them as part of a single connected system. It wasn't describing one creature anymore, it was describing something distributed. Here's what that actually meant once it was laid out in full. The model had identified coordination across what should have been completely unconnected individual creatures, separated by hundreds of miles and sometimes by generations, behaving in ways that only make sense if they were responding to something at a population level, rather than as isolated animals, each making their own decisions in their own territory. The clustering, the movement correlation, the avoidance pattern, the binary response to sustained observation, none of those were separate anomalies anymore. They were pieces of a single behavior distributed across what the data suggested could be dozens, possibly hundreds, of individuals acting with a level of consistency that no known species exhibits, especially not one this elusive, this spread out, this rarely confirmed to even exist in the first place. It wasn't a creature avoiding cameras here and there out of caution. It was something that understood it was being studied and was responding to that fact collectively, the same way, everywhere, every time. That's the part neither of us had a framework for. Not the existence of the creature itself, the coordination behind how it was responding to us. Once that settled, the obvious question became how something like that would even be possible. Coordination at that scale, across that kind of distance, usually requires some form of communication. Migratory birds use environmental cues. Wolves use scent marking and vocalization within a pack. Even highly social species with complex behavior need some mechanism to actually transmit information between individuals. Nothing in the data suggested anything like that here. No vocalization patterns linking distant sightings. No evidence of any shared physical trail connecting populations that should have had zero contact with each other. Whatever this is, it isn't coordinating the way anything else in the natural world coordinates. The behavior pattern exists. The mechanism behind it doesn't show up anywhere in 10,000 reports. That gap is what made the deeper output so hard to sit with. It wasn't just confirming something stranger than expected. It was confirming a result with no explanation attached to it at all. One part of the analysis kept bothering me. As part of the original project, the AI had apparently been asked to do something beyond simply analyze the sightings. It was asked to take the patterns it identified and project them forward. Before getting into that part, I asked what exactly the model was doing. Was it generating entirely new scenarios or simply extending the trends it had already identified? The answer was the latter. It wasn't making predictions from scratch. It was taking the behavioral patterns that had survived multiple rounds of testing and projecting them forward to see where they led. I'm not going to walk through that projection in detail, not because I'm trying to be dramatic about it, but because the moment you start putting numbers, timelines, or predictions on something like this, you're stepping beyond confirmed data and into assumptions. And if there's one thing that stood out to me throughout this entire project, it's that the people behind it seemed unusually careful about separating observations from speculation. What I will say is that the projection wasn't reassuring. The details varied depending on the assumptions being used, but the overall conclusion was enough to make people uncomfortable. In fact, from everything I've been able to find, it's the one part of the analysis that those closest to it have been the most reluctant to discuss publicly. Even when they talk about the patterns the AI uncovered, they tend to stop short of talking about where those patterns appeared to lead. The more I looked into it, the more I realized that hesitation wasn't really about secrecy. It was about responsibility. Once the deeper findings had been reviewed, the conversation seemed to shift away from what had been found and toward how it should be talked about. And honestly, I can understand why. The problem with releasing part of a finding without the rest of the context is that people tend to fill in the gaps themselves. A few details get repeated, theories start forming around them, and before long, the discussion ends up somewhere the original data never pointed in the first place. That's a concern I heard again and again while looking into this. Not that people would learn too much, but that they'd learn too little and start drawing conclusions from an incomplete picture. Because of that, the information that's been made public so far has been released carefully, slowly, piece by piece rather than all at once. When I first came across this story, I wasn't sure why that level of caution was necessary. By the end of it, I understood. I keep thinking about that one line in the research note that started all of this. At the time, it seemed like a passing detail, something I probably should have forgotten 5 minutes later. Instead, it sent me down a path I never expected to follow. The deeper I looked, the harder it became to fit the results into any of the usual explanations. The people behind the analysis didn't just settle on a conclusion and work backward from it. They tested for reporting bias. They looked at the possibility of cultural influence. They compared the patterns against known animal behavior. Again and again, they tried to find a simpler explanation for what the data was showing. And according to the analysis, none of those explanations fully accounted for the pattern that emerged. What's left is something far stranger, a pattern that appears across thousands of reports over huge distances and long periods of time, and one that the model identified as being far more organized than anyone expected. More than that, it pointed toward behavior that seemed to change when observation itself became part of the equation. What happens next is still unclear. How this gets studied from here, who else ends up reviewing the data, and how much of it eventually becomes public are all questions that are still being worked through. But the findings themselves aren't going anywhere, and every now and then I find myself thinking about how easily I could have scrolled right past that one sentence and never looked into any of it at all. The strangest part isn't any single anomaly. It's how every explanation that should have closed this out fell apart the closer anyone looked at it. Reporting bias didn't survive. Cultural contamination didn't survive. Migration, territory, instinct, none of it survived contact with the data. What was left when all of that got stripped away wasn't a simpler answer. It was a bigger question, sitting there waiting for someone to finally ask it out loud. Google's AI analyzed 10,000 Bigfoot sightings, and what it found was something that, by every measure we have, shouldn't exist at all.